Hi students, welcome back. In this week video, we'll be doing cubic polynomials and equations. The questions we'll be doing are from exercise 4.3. Alright, before we attempt to do the questions from exercise 4.3, we need to understand some concepts. So what are they? For example, sometimes you may see questions as such. Factorize x cubed plus x squared minus x minus 1. Or it could be solve x cubed plus x squared minus x minus 1 equals to 0. Right, so do you know the difference? Right, let's look at factorize first. So when you ask to factorize a polynomial, it means you are asked to break the polynomials into linear factors. So your answer would be something like this. Right, so you see that there are 3 linear factors. And if you were to rewrite it, we can see that this is a pair of repeated linear factors, and we can actually put them together to get bracket x plus 1 close bracket squared. So that explained how I get the answer here. Alright, so to recap, when you ask to factorize a polynomial, it means you break the polynomials into linear factors, and that's it. But how about solving a quadratic or cubic equations or any equations? So if you see the word solved, right, what we are doing is most of the time you'll be given a equation instead. An equation is where you have equals to something. Something equals to something. Alright, an equation. So to solve the equation means we are asked to find the values of x that satisfy the cubic equations. Right? So to do that, we have to first factorize it. Okay? To first factorize it to get the linear factors. And then we apply the AB product rules. If you were to remember, what is AB product rule? It means it can be x bracket x plus 1 to the power of 2 equals to 0, or x minus 1 equals to 0. And from there, we solved the values of x, which could be negative 1 or 1. So when you solved the equations, means you are finding the values of x that satisfy the equations. But when you also factorize it, you are actually expressing your answer in linear factors. Right, so to summarize, factorizing a polynomial, your answer will be in linear factors. Basically, just bracket, bracket, bracket. But if you're asked to solve it, means you're finding a specific values for x. Alright, so the next thing is we need to make friends with cubic curves. Right, we need to understand the problem, understand our friend. We need to know the characteristic of our friends. Because when we know them well, then we'll be able to solve the problems that is related to them. So what are the possible cubic curves that we may encounter? So it could be case 1, where the cubic curve has 3 solutions or 3 distinct roots. Or it could be case 2, where the cubic curve has only 1 solution, that is x equals to 0. So there's only 1 real root, that is x equals to 0. Or case number 3, where it could be, in this case here, can you see that there's a pair of repeated roots, and it happens here? X equals to 1 is repeated, and then another real root, that's x equals to negative 0.5, Or it could be case 4, where there's only one real root. And for this part of the curve, okay, there is no real root at all. Right, so these are the 4 possible kind of cubic curves that we need to make friends with. And of course, there are other possible. It all depends on, okay, the general form of the cubic curve will be ax cubed plus bx squared plus cx plus d. So when I say there are other possible curves, it means that your a can be positive value or a can be a negative value, right? So if a is a positive value, then the curve will be different from the curve where your a is a negative values. However, the types of roots that the cubic curves have will be just these 4 cases. It means the cubic curve can have 3 distinct real roots, can have 1 real root where x is equal to 0, can have 1 real root and 2 repeated roots, or case number 4 is just 1 real root only, and it is not x equals to 0. If you look at case 4 and case 2, they are not the same. Alright, case 2 it's 1 real root, but here x is equals to 0. But if you look at case 4, x is not equal to 0. It can be other values. Okay? Alright, in this advanced age, the calculator can actually help us to check a lot of answers before we submit our scripts in the exam. Such as, for example, after finding the roots of the polynomial, using the showing all the calculations, all the steps properly, and then if you want to verify if your answers are correct or wrong, you can actually use a calculator to help you verify the answer. So depending on the types of calculators, the brand of the calculators are using, you can actually go to YouTube and Google on how you can use it. You can actually use this thing called mode 3 or something like you press equations, polynomial, degree 3 or 4, that kind of things to help you find the roots of the polynomial. However, we need to understand how we use the calculator effectively. Because the difference between okay, when you use a calculator to help us find the roots of the equations, we are actually solving an equation, right? So for example, the case that that's shown on the screen, if I ask to solve 2x cubed plus x squared minus 2x minus 1 equals to 0, and if you were to use a calculator, to help you key in your values of a, which is 2, values of b, which is 1, c is negative 2, d is negative 1, the answers that you see on the calculator screen will be x equals to 1, x equals to negative half, or x equals to negative 1. So these are the 3 roots of your cubic equations. Okay? If you are asked to solve another cubic equation, but now it's negative 2x cubed minus x squared plus 2x plus 1 equals to 0, you will see that you will get the same answer. You will still get x equals to 1, x equals to negative half, or x equals to negative 1. Because when you solve for equations, you are just finding the values of x that satisfy the equation. So why is it that even though the coefficients of x cubed here is 2, coefficients of x cubed here is negative 2, why is it that the answers are still the same when you use a calculator? It's because from your negative 2x cubed minus x squared plus 2x plus 1 equals to 0, you can actually multiply by negative on both sides. Can you see multiply by negative on both sides? And you still end up getting 2x cubed plus x squared minus 2x minus 1 equals to 0. Okay, so in both situations, you're actually finding the values of x that satisfy the equation. Okay, I don't know whether I have explained this well enough for you to understand. The story is different when you are doing factorization. Okay, when you are doing factorization, let's say if you ask to factorize this guy, okay, the three linear factors will be x minus 1, 2x plus 1, and x plus 1. These are the 3 linear factors. Alright, however, when you ask to factorize, Negative 2x cubed minus x squared plus 2x plus 1, then it's a different story. Can you see now that the coefficients of x cubed is negative 2? And hence, you see I need to have a negative there. Okay, because if you take the first term here and multiply with the first term of this second linear factor with the first term of the third linear factor, you actually get 2x cubed. Alright, but your polynomial is negative 2x cubed. Hence, you need to have a negative there. Alright, so can you see the difference between solving equations versus factorizing it? Okay, so here comes the tricky part. Here comes the tricky part. So when, not tricky. So when you use the calculator to help you to factorize a cubic polynomial, alright, we can actually get from the solutions and work backwards, right? It's actually from your solutions you can work backwards to get the linear factor, right? So you have to be very careful, alright? If you are factorizing a polynomial with a negative coefficients of x cubed, then you should factorize it first. What I'm saying is that from here, you should factorize a negative out first. Right, and then use your calculator to find the linear factors. Okay, the calculator will not help you to find linear factor. The calculator actually give you the solutions, the roots, and from the roots, you convert it into linear factors. Alright. Okay, I don't know whether I've explained this well. Okay, never mind. I will give you an example in the next slide. Alright. I need you folks to be patient with me. I will try to explain the story as clear as possible. So this is supposing we are asked to factorize 2x cubed plus x squared minus 2x minus 1. And supposing we have done all the necessary working, everything, we work very hard, all the steps, and we come out to have these three linear factors, right? And we want to use the calculator to help us verify if our answers are correct. Right, so we use the calculator and then we key in the values for A, which is 2, B, which is 1, C is negative 2, and C is negative 1, right? And then the calculator will give us the answer x equals to 1, x equals to negative half, or x equals to negative 1, right? So we are going to convert all this into linear factors. Alright, so if you convert it into linear factors, this one means x minus 1 equals to 0, right? It's from x minus 1 equals to 0, then you get x equals to 1, right? So this is the linear factor. And then for this chap here, alright, if you were to work backwards, right, you need to multiply by 2 on both sides to get 2x equals to negative 1, right? And then work some more, will be 2x plus 1 equals to 0. It's from 2x plus 1 equals to 0, and then you get x equals to negative half, right? So this is our linear factor, right? Likewise for this, okay, it's from here like that, right? Then you end up getting x equals to negative 1, right? So this is our third linear factor, right? So when I put them together, that means my 2x cubed plus x squared minus 2x minus 1, put them together, the three linear factors will be x minus 1, 2x plus 1, and x plus 1. Okay, that is happiness. You get the answer, right? Okay, so the problem arises when what happened? When, let's say, if you're given this, right? And you use a calculator, you happily use a calculator, right? You key in A equals to negative 2, B equals to negative 1, C equals to 2, D equals to 1, right? Right, then the calculator will show you x equals to 1. So you convert it, will be x minus 1, right, into linear factor. Then the second answer will be x equals to negative half. you convert it, you will get 2x plus 1. And then the third one will be x equals to -1. You convert it, you get x plus 1. Right, and then you write it out, your answer. But your answers is not correct. Okay? Your answers is not correct. Why is it not correct? Because when you take this guy times this, you end up 2x cubed. Whereas the original questions you're given is -2x cubed. Okay? So to avoid this kind of mistake, right? When you have a polynomial where when you need to find the linear factor, I'm not saying solving it, solving it has no problem. If you have a polynomial when this is a negative coefficients of x cubed, and if you need to find one linear factor, then what do? Then you should factorize your negative out first. Okay, if you don't quite understand what I'm saying, please watch it a few times, because definitely it's not easy. So if you're going to use the calculator to help you find the linear factors, okay, factorization, then if you have a negative coefficients of x cubed, factorize your negative out first. Right, then use your calculator to key in your a. Right, and then you will get the correct answer. Because this one here will be the same as what they've done here. Oh, sorry, this guy is D. Okay, then you will get the correct answer, but there's a negative in front. Oh, not so many linear factor, 3 only. Okay, or if you do not want to factorize it, right, if you do not want to factorize it negative out, then after getting your linear factors, just ensure that you have a negative there. Alright, so there's a difference between solving and factorizing. Well, I hope I've explained it clearly enough for you to understand. If not, please check with me again. Right, so I'm going to do two examples. Alright, two examples before we actually go into solving the questions from exercise 4.3. So this is rather is a very long video, so it's good that you can just break it up into two sections. Alright, the first session is understanding the concepts, and then the second session then really go into the exercise 4.3 proper. Right, so if you look at the example 17, you're asked to solve the equations. Right, so we need to simplify it first. Simplify as in expand it. So we would get x squared, 5x squared minus 2x cubed equals to 4. And then rearrange it again. Alright, and I'm going to multiply by negative throughout to make the coefficients of x cubed positive. So the first step is just to give your polynomial a name. Right, it's important that we show respect to our polynomial. So I'm going to call it g of x. Alright, so I'm going to use the calculator to help us find a solution, a root. Okay, a root. So I'm going to use, I'm using Casio FX96 SG plus. So I'm going to click on mode, and then number 3, that will show. Number 3 is for equation, and I'm going to choose number 4 because I'm using cubic. I'm dealing with a cubic polynomial. So the coefficients of x cubed will be 2. Coefficients of b will be -5. and there's no x term there, so the coefficients of x term will be 0. The constant is the one without any x term, so that will be 4. Alright, so on your calculator screen, you will see x1 equals to negative 0. Blah blah blah. So that is not the whole number. So we're not interested in that. The second value is x equals to 2. And the third value, again, it's an irrational number, 1.28, blah, blah, blah. So we would choose the answer that it's an integer. Okay, so the integer is x equals to 2. So x equals to 2, it's one of our solution, one of our roots, one of our solution. So therefore, we're going to let x equals to 2. And we know very well that if I were to substitute x equals to 2 into our polynomial, now we already learned factor theorem, right? So if you're going to substitute x to be 2 in our gx, you're going to get remainder 0. Okay, and so therefore we conclude from here we have to work backwards, right? So I'm going to convert x equals to 2 into a linear factor, then it will be x minus 2. So therefore x minus 2 is a factor of g of x. Right, so that's the first step, right? Then the second step is we will have to find the remaining factors. Okay, that is quite bad. This one, I draw the line like someone not having enough sleep. Okay, so this is better. Right. So I need to, okay, where am I? That's the problem. Need to focus. Alright, so I have 2x cubed minus 5x squared plus 4. So this cubic polynomial will be equals to a linear factor, right? Multiply with the quadratic formula. Okay, a linear, this guy is a linear, and this one will be a quadratic. So do you remember the general form of a quadratic polynomial? Okay, I count to 5 for you to think about it. 1, 2, 3, 4, 5. Yes, you are right. It's ax squared plus bx plus c. Okay, now the very long-winded method, the super long-winded method is to expand this out. Expand every terms out, okay, every term. If you take x times ax squared. Okay, I'm just going to do it for you, okay? Please be patient with me, alright? Please be patient because this chapter is not easy. So if you're going to expand it out, right, then whatever x cubed term here, right, will be equal to your x cubed term on the left. Okay? Whatever x squared term here, this guy will be equals to your x squared term here. And because the cx term, it will be equals to 0x on the left hand side because on the left hand side there's no x term, right? So your cx minus 2bx will be equals to 0. And whatever that is does not have an x or x squared or x cubed, that means your constant, which is your negative 2c, will be equals to positive 4, right? So this is a rather long method of doing it. If you wish to do it that way, I would strongly encourage you not to because it's very time consuming. Okay, but the concept is like that. The concept is whatever we expand on the right hand side, it will be equals to whatever you see on the left hand side. Right, so what is the shorter method? So if you look at what we have in the first term, right, the first term is ax cubed, right? So your ax cubed is equals to 2x cubed. So the one is can be found quite easily. Okay, I'm going to erase this. Quite easily found by just taking the first term of your linear factor multiply with the first term of your quadratic factor. Okay, right, I'm going to erase this because if not, it's very confusing. So now you understand the concepts behind. Okay, if you do not, then watch the video again, please. Okay, so right, so now we know that the one that I've circled multiply the one that I've circled, right, will give me this one here, right? So therefore, x times ax squared will be x times ax squared will be ax cubed, will be equals to my 2x cubed. If we divide by x cubed on both sides, then a is 2. That's how we found our values of a, right? Okay, and if we were to remember also that the constant term is by taking the constant terms of your linear factor, which is -2. Can I just erase all this because it's like so confusing? I find it very confusing. Don't know whether you find it confusing or not. Okay, right. So the constant terms of your first linear factor, right, you multiply with your constant term of your quadratic polynomial. So it's -2 times c gives you -2c, will gives you your constant term on the left hand side, which is +4. Then from here, c is -2, right? Okay, so what remains is the x squared and the x term, right? Okay, which is this. We need to find the unknowns b. So we already settled with the x cubed term and the constant term. So what remains is the x squared and the x term. So it depends on whether you want to compare the x term or the x squared term. Okay, so if you want to compare the x squared term, let me show it to you, all right? So please be patient with me, all right? I'm asking you to be patient with me. If I'm going to get my... So I'm going to put in my a and my value for c because I already found it. All right, so if I'm going to compare my x squared term, then I will need to fish out all the x term from here, all the x term from here. Right, so we have to do it slowly. Go to the first term of your linear factor first, x, multiply with this guy. When you take x times 2x squared, you get 2x cubed, which is not your x squared term. So this one I'm not interested. Go back again to the second one. Okay, let me write down what I need to find on the left hand side first. Okay, x times bx. Yes, I get bx squared. So this is what I'm keen on. And then try again the last one. Of course, the last one gives you -2x, which is not what you want. Okay, and you don't end there. You don't end there, okay? Because your linear factors has two terms, that x and -2. So once you're finished with x, you have to go on to -2. So if you look at -2, all right, take this, multiply with the first term of your quadratic polynomial, -4x squared. Yes, that is what you want. Okay, you go on to this, is -2bx. I'm sorry, this is not what you want. And of course, -2 times -2 will give you a 4. All right, so you divide by x squared on both sides, you get -5 equals to b minus 4. So b minus 4 is equals to -5. b will be equals to -1. Okay, right. So supposing you don't want to compare x squared, you want to compare x term. If you look at the left hand side, the x term is 0, so that will be 0x. Okay, right, so we repeat the process of what we have done. Take x times 2x squared, no. You end up x cubed. Take x times bx, also no. But if you take x times -2, yes, I have my x term there. Then go back to -2. You must be fair, okay? There are two terms in the linear factor. You work on x, you must also work on -2. Okay, so -2 times 2x, -4x squared, no, no. What? No, yes, -2 times bx, -2bx. Yes, this is what I want. All right, so I divide by x on both sides will be 0 equals to -2 minus 2b. -2 minus 2b equals to 0. -2b equals to 2. And b equals to -1. Can you see? You get the same answer. All right, so you just need to choose. To find the unknowns b, you just need to choose whether you want to compare x squared term or x term. Okay, right. Okay, I need to erase this thing here because if not, I have no space to continue. So if I've forgotten the earlier parts, right, please go back and watch the video again from the beginning. Okay, I'm sorry because I don't have much space. I can't squeeze everything into one slide. And if you go on to the next slide, you may have forgotten what we have done earlier. Okay, so I'm going to continue the story here. So what I have will be x minus 2 followed by 2x squared. My b is negative 1, so negative x minus 2 and then equals to 0. So I need to solve it. So solve it means to find the values of x, right? So it's either x minus 2 equals to 0 or alright. So if you were to use your calculator to help you find the solution, you'll realize that your answers has a lot of decimal places. Irrational number. Okay, there will be irrational number. So always go back to the conditions, the questions, the requirement, sorry, the requirement of the questions. In this case here, the questions require you to leave the answer in cert form. Cert form, that means cert. Okay, we have learned cert in chapter 3. So therefore, you can't use a calculator to help you further. So there are certain times where you have to stop using the you can continue use a calculator, sorry, but you can't really use it further to help you get the answer. So in this case here, then how do I go about solving it? Yes, you use quadratic formula. Okay, so using the calculator only can extend to a certain part. Then most of it you have to lean back on the concept. So the quadratic formula is also write down the values for your A, B, C. To substitute into your quadratic formula, so quadratic formula is x equals to negative b plus minus right, so you substitute inside. So one answer is x equals to 2. So substitute negative, then bracket negative 1 plus minus bracket negative 1 squared minus 4 2 negative 2 over 2 times 2. So this will work out to be 1 plus minus 1 plus 4 times 2 times 2, 17 over 4. Okay, so there will be 3 solutions there. X equals to 2 is one solution. X equals to 1 plus square root 17 over 4 is one solution. The other solution will be 1 minus square root 17 over 4. You can put them together, no problem. Alright. Alright, let's look at another question. And in this question here, we are asked to show that the particular equation has only one real root. So not to worry, when the questions ask you to show something, it means basically you just need to solve it. Just need to solve as per normal, and then the answers you get at the end will only have one real root. And if you were to recall the types of curves that we were talking about earlier on, right, it will be something like this. Okay, there's only one real root here. All right, so let's get on to our questions. Let's expand this one first. So x cubed plus 6x minus 3x squared minus 8 equals to 0. Rearrange it in ax cubed followed by bx squared followed by cx followed by d. Because the general form of your cubic polynomial is ax cubed plus bx squared plus cx plus d. Okay? Alright. Okay, right. So first thing first, let's respect our polynomial. We're going to call it gx. Alright, and the coefficients of x cubed is a positive one, so you can just use your calculator to help you find one solution. Yes, okay, this one is positive 1, so no problem. Remember what I told you, if it's a negative, then you will just have to convert it into positive. When you're solving it, when you're factorizing it, then you just factorize it. Okay, if you can't understand what I'm saying, go back to the previous slides. the difference between factorization and solving. Alright, so now we key in the values of A, which is positive 1, B, it's negative 3, C, it's 6, D, it's negative 8. Okay, so on your screen, you will see x equals to 2, one solution, and then I'm not going to continue now. That's the whole number already integer, so I'm just going to use it. So I'm going to let x equals to 2. So g of 2 will be equals to 0. Okay, so therefore x minus 2 is a factor. Alright, x minus 2 is a factor. Okay, so then the next step is if you to recall. Right, so therefore x cubed is equals to x minus 2 multiplied with your quadratic polynomial. Alright, we're going to find the first term. So this multiplied by this will be ax cubed, right? Will be equals to your x cubed term here. Divide by x cubed on both sides, so a is 1. Right, so I'm just going to replace this with 1, okay? And then the next one is to find my constant term. So that will be negative 2c. So negative 2c will be equals to this number here. So c will be 4, right? So I'm just going to replace my c with 4. Okay? Alright, so what I'm left is this unknown here. So I'm going to compare again, up to you. You want to compare the x term or the x squared term. I'm just going to use negative 3x squared. Okay, so take the first term of your linear factor x. You need to multiply with this to get bx squared. Go back to your linear factor because the linear factor has two terms there. X is negative 2 is the other one, so negative 2 times this guy here. I'm interested in the x squared term. Alright, divide by x squared on both sides. Negative 3, it's b minus 2. B minus 2 equals to negative 3. So b, it's negative 1. Okay. Let's try to be neater. Right, so what I have, it's x minus 2 followed by x squared minus x plus 4 equals to 0. Right, so apply the AB product rule terms. So x minus 2 equals to 0. That will give me x equals to 2. Or this guy. Right, actually, if the question says that show that it has only one real root, right, that's already a hint to tell you that for this chap here, there's no real solution. So if we were to link this back to your quadratic inequality you learned early on, the discriminant thing, we can actually find the discriminant for this quadratic equation. As long as we can show that it is a negative value. Right, which is a negative value. If the discriminant is a negative value, then therefore there is no real root. There is no real root for the above equation, right? For x squared minus x plus 4 equals to 0. Okay, so therefore x equals to 2 is the only one real root for the equation. Alright, so this is how you go about solving cubic equations. Okay, so this value here is 2, x equals to 2. And then for this part, there's no real solution. This part here, there's no real solution. And this value here, do you know how to find this value? This value is when x is equal to 0, right? So when you substitute x is 0 is negative 8. Oh, negative 8. Huh? Negative 8. Wait, hang on. When I substitute x to be 0, right, so my curve is wrong because the y coordinate has to be negative 8. So in this case here, this is wrong. Let me try to draw again. So it would have to be, right, so there is a real root here which is 2, and then it cuts at negative 8. So I think it's something like this, all the way down. Interesting curve. Okay, it comes here, touch at x equals to 2, y equals to negative 8, and come all the way down. Alright, interesting. Right, so we have done some concepts, solving cubic equations, factorizing cubic polynomials. Now let's go on to solving the questions from exercise 4.3. Okay, the first one is relatively easy. You're given a polynomial that's x cubed minus 3x squared minus 4x, and then you ask to solve it when fx is equals to 0. Right, so when fx is equal to 0, basically you're just solving x cubed minus 3x squared minus 4x equals to 0. And for these questions here, there is no need to use your calculator to find one linear factor, because if you were to observe it carefully, we have a common factor x. Alright, where can you just happily factorize it out to get x, and then bracket x squared minus 3x minus 4. So if you were to apply the weight, so we can go on to factorize this. This is a quadratic formula. This one you can actually use a calculator to help you get your linear factors. And then this step here, we apply your AB product rule, that is x equals to 0, or this linear factor equals to 0, or this equals to 0. So the answers here will be 0, 4, or negative 1. Alright, let's look at part 2, when your f of x is equals to negative 12. Right, so when f of x is negative 12, basically it's just x cubed minus 3x squared minus 4x equals to negative 12. And then you bring everything to the left hand side. And then we just give a name to your polynomial. We're going to call it g of x. Right, so here you can use your calculator. That is where the calculator comes in useful. We can use it to find a linear factor. And the coefficients of x cubed is positive 1. Alright, so we have no problem with that. Alright, so we can key in your values of a, b, c, d, and then one of the solutions will be x equals to 2. So g of 2 will be equals to 0 using factor theorem. Then the next step is, yes, therefore x minus 2 is a factor of gx. And then the next thing is just to rewrite it as in x cubed minus 3x squared minus 4x plus 12 is equals to your linear factor x minus 2 multiplied with a quadratic polynomial. A linear times a quadratic will give you a cubic. Alright, so this is your linear. This one is your quadratic. And you will get this one is your cubic. Alright, okay, so we're going to find the first term. So the first term is quite easy, which is just ax cubed equals to x cubed. So therefore a is equals to 1. And then we're going to find the constant term. The constant term is just negative 2 times positive c gives you 12. And c is negative 6. So after finding the values of a and c, let's put it back into your quadratic polynomial. Yeah, so we are left now with to find the unknowns b. So we need to find this value here. So I'm going to compare the x term. You can go ahead to compare the x squared term, which I've already explained in the earlier slides. So if you have forgotten, please refer to the earlier slides. So negative 4x will give you negative 2bx minus 6x. From here, you simplify to get b equals to negative 1. And then the next step is to put everything back into your equations. Alright, and then you can use a calculator again to find the linear factors for this guy. And using the AB product rule, your answers will be x equals to 2, 3, or negative 2. And that's how we solve question 3, part 2. Right, so for question 5, you're asked if every polynomial of the degree 3 has 3 x-intercepts. And if it's not true, then give an example to support your answer. Right, this is not new, because if you were to recall the earlier slides on the types of concepts that we need to solve cubic equations or factorized cubic polynomial, we learned about making friends with the different types of cubic curves. So let's run through all the different types of cubic curves again. Right, so case number 1, it could be the curve has 3 x-intercepts, right, 3 distinct roots. But it can also be such a case where there's only one real solution, that's x equals to 0. Or it could be, oh, case 4 came out for us, never mind. Or it could be a case 4 where it's one real roots, only one real roots. Or case number 3 could be a real roots, one real roots, and the other one is repeated. Okay, so in this case here, it depends on which case you want to state. You can state case 2 as an example to show that it is not true, right? Because you can have x equals to 0. There's only one x-intercept, all right? Or you can state case 3, right, where there are only 2 x-intercepts, okay, because 2 of the roots are repeated. Or it could be case 4, or it could even be the one we did earlier on. Remember the curve that we did earlier on, something like this, where it only touches x equals to 2, y equals to negative 8, and then go all the way down. So it also means it's only one x-intercept. Right, so you can just use any of the cases here, but except case 1, because case 1 has 3 x-intercepts. Okay, so you can use case 2, case 3, or case 4. Right. Alright, so let's look at 9, part 1. Show that 2x plus 1 is a factor. Alright, so to show something is a factor means to show that that polynomial that we're given has no remainder. Right, if it's a factor means the remainder is 0. So we need to show that the remainder is 0. So first thing first, we need to respect our polynomial. So we're going to call it a of x. So we're going to let a of x equals to 2x cubed minus x squared plus 3x plus 2. All right. Oh, we don't need a bracket there. I'm sorry. Okay, so the next thing is that to show that 2x plus 1 equals to the factor, okay, means that if you work backwards, right, we can find, you see, we can use solutions and work backwards to find factor. We can also use a factor to work backwards to find solution. So the solutions will be 2x equals to negative 1, x equals to negative half. So basically what we're going to do is that we're going to substitute x to be negative half and see what kind of remainder we'll get for it. This one, it's using factor theorem. So if you've forgotten your factor theorem, please revisit 4.1 and 4.2. All right. So need to put in more effort, lor. Comes to buck up a bit, lor. And you can do it, huh? I'm using the calculator now to verify. Yes, and on the calculator screens, I get 0 as the answer. Right, so we need to do some explanation. Okay, we don't stop here. The important things of a good presentation is to be able to explain your solutions such that anyone can understand it. Right, so how do you go about explaining it? We just say that since remainder is equals to 0, using factor theorem, 2x plus 1 is a factor of a of x. Alright, so that's just part 1. Alright, so part 2 show that the equations has only one real root. Okay, so this one is similar to what we have done earlier. I think it's example, is it 17 or 16? Alright, so first thing first, we need to simplify the expansion. We need to expand this one. That will give us x times x minus 2 minus 1 times x minus 2, 2x cubed plus 4, x squared minus 2x minus x plus 2. Put everything to the left hand side. Minus 3x. I need to be a bit more careful because no, it's plus 3x. I don't want to redo. It's very torturing having to redo 2x cubed minus x squared plus 3x, okay? Then 4 minus 2 is plus 2, yeah. Alright, let's give our polynomial a name. Call b of x, can? Alright, b of x, 2x cubed. Alright, so do you remember how we go about doing it? Yes, use your calculator to help us find one solution and then convert it to linear factor. So the coefficients of x cubed is 2, so no problem. So use your calculator. Mine is Casio, so mode 3 for coefficients of a is 2, b is negative 1, c is 3, constant term, the d is 2. Alright, so I have the first value that's negative half. I'll prefer to use a whole number. Second one is a bit weird. Okay lah, no choice. As in I have need to use x equals to negative half. Right, so you get x equals to negative half, right? So I need to convert it. So let x equals to negative half. So b of negative half will give me remainder 0. Okay, so I need to convert this guy into a linear factor, right? So times 2 on both sides, will give you 2x equals to negative 1. Convert it further will be 2x plus 1. So therefore 2x plus 1, it's a linear factor. It's a factor, don't need linear. It's a factor of b of x. So the next step is just as per normal, equals to our linear factor, which is 2x plus 1, multiply with our quadratic polynomial. Alright, and then go on to find your a, b, and c. So the first term, your a term will be just 2ax cubed equals to 2x cubed. Divide by 2x cubed on both sides. A is 1. Go on to find your b, which is just 1 times c. C equals to 2. Alright, then put everything back again into your identities. Okay, so the more troublesome one is the b term. I'm just going to compare our 3x. You can compare your x squared term, okay? So this will give me 4x. So you see that once I know the concept right, it's very easy. Okay? Divide by x on both sides. So of course the first few times when you do it, it's a bit difficult lah. Right, but you have to practice. Math is all about practicing it lah. Okay? Alright. So what's the next thing I do? Found my A, B, C already. I can just put it back again into here. Right, and then I need to solve it, right? Need to solve it. So therefore, 2x plus 1 and this chap here is equals to 0. Right, so x can be equals to negative half. So all this equals. Alright, so the question says has only one real root. So give us the hints to say that there's no real solution for this. So we just apply discriminant to find the values of discriminant and see if it's less than 0. And you end up getting 1 minus 8 to negative 7 less than 0. Okay, just need to do my explanation here. Right, so since Okay, don't need to write since because we already showed that discriminant is less than 0, so we can just conclude that there is no real root. There's no, you need to explain it well, okay? There's no real root for x squared minus x plus 2 equals to 0. So therefore, x equals to negative half is the only one real root. Is the only one real root. Okay, this is how we do it. Right. Alright, so to do these questions, we have to apply two formulas that we have learned earlier on, the sums of the cubes and the difference of the cubes. Sums of the cubes, which is your a cubed plus b cubed. So this formula, you have to memorize it, but it's not difficult to memorize. A cubed plus, if your operation is a plus, then you just start with plus, which is just a plus b, and then followed by a squared, then minus ab. Okay, do not confuse with your quadratic, do not confuse with your algebraic identity. Your algebraic identity is a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, right? Here it is negative ab. Okay, it's a squared minus ab. Okay, do not confuse with your algebraic identity. And then the second one, it's the difference. So you will start with a minus b, followed by a squared, then plus, all the way plus. Okay, right, so this formula, make an effort to memorize it. Don't wait until the exam or the test to memorize. Do it now. Every day remember a little bit, and you'll be in a long-term memory. So let's look at part A. Part A is relatively, I wouldn't say relatively easy. I always like to say relatively easy because I find that some of you really struggle quite a lot. So I'm going to use this thing, instead of using easy, I say manageable. Okay, rather manageable. If you were to examine the polynomial given, you see that there's a common factor 2 where you can put it out. There's also the common factor x that you can put it out. Okay, so do not jump into the applications of the formula. Always factorize. Always ask yourself if there's anything that I can extract it out first. So yeah, so like what we mentioned earlier, I can just pull out 2x, and that will give us x cubed plus 54 divided by 2, that's 27. Okay, and here we can just apply this one here. Okay, because it's x cubed plus something. But of course, I need to write 27 as cube of a number, which by now, yes, all of you are proficient enough to know that it's 3 cubed. 3 cubed give you 27. Okay, so like what I've mentioned earlier on, to do this well, the best is to put it in bracket. If you know how, just put in bracket, right? So I need the first bracket. You see, first of all, I need one bracket here, right? Okay, so this is my first bracket, followed by a huge bracket, and then I need a bracket for a squared, followed by negative, followed by a bracket for a, bracket for b, followed by plus, and then another bracket for b squared, and then close it up. Okay, then the next thing is just fill in the brackets. So x will be just your a, b will just be your 3. So the next thing is a squared. So just a squared minus a, it's, wait, what am I doing? Your a is x. Oh, I'm also confused. Okay, I tell you what, if you're like me, very confused people, right? Just put a little a here. So I'm going to substitute a for x and then substitute b for 3. So a plus b means x plus 3. Then followed by a squared, right? A squared, which is x squared. A is the value for x, then b is 3, followed by b squared, that is 3 squared. Okay, then simplify. So this will just be x squared minus, this will be 3x. You can just remove the bracket and then plus 9. Alright, so that's the answer. Okay, So when you first do it, yeah, it's a bit confusing. Yeah, I must admit it's a bit confusing. Right. So no, don't worry. Let's do the next one. So we can write 64 X4 to the power of 3. So if you do like what I've done, it will not be confusing. So this guy I'm going to substitute in for A. This one substitute for B. Alright, and then remember what we have done earlier on. This is a plus, so I must use the one with plus, the sum of cubes. I must use sum of cube because the operation in the middle is a plus. Alright, so we need to have a bracket first, right? And then a square bracket, right? And then another bracket, minus bracket, 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 plus another bracket, and then square bracket. So the first bracket is a plus b, a plus b. So that will be 1 plus x plus 4. The second one is a squared. So a squared will just be 1 plus x to the power 2 minus a is 1 plus x, your b is 4, then followed by 4 squared. Okay? Right, so this one we can simplify further to be x plus 5. This one you need to expand it. Will give me this. This one also need to expand. Will give me 4. Okay, watch out. Minus 4x. 4 squared is 16. Right, simplify further. Put x squared first, so x squared. Then followed by 2x minus 4x will be negative 2x. 1 minus 4, negative 3. Negative 3 plus 16 plus 13. Okay, right. Alright, let's look at part C. I don't know whether you have enough space to do that, but not to worry. We'll try. Okay, so finally we have to do the difference of cube because this guy is minus. So we're going to substitute this for A, substitute this for B, alright? So as usual, let's start off by putting in all the brackets. So I need a bracket first, right? Followed by a square bracket and then another bracket. And this time here I'm using this one, some difference of cubes. So it will be plus bracket, 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 plus another bracket and then square bracket. Okay, so the first bracket is A minus B. A minus B, so that will be x plus y minus bracket x minus y. And then A squared, that will be x plus y squared. Followed by, ayo, so confusing. Okay, then followed by x minus y squared. Okay, so it's confusing. That's why we have to do it carefully. Okay, we have to do it carefully. Right, so if you simplify the first bracket, that will be x plus y minus x plus y. So that gives you 2y. Right, because x minus x will be gone, y minus minus y will be y plus y, so 2y. And then we need to expand this term here, so that gives us x squared plus 2xy plus y squared. Expand this one here will just give us your x squared minus y squared. Remember, a plus b times a minus b is a squared minus b squared. Expand this one here will give us x squared minus 2xy plus y squared. Simplify further. X squared plus x squared plus x squared. That gives us 3x squared. 2xy minus 2xy, so it's gone. Y squared minus y squared gone, so left only 1y squared. Oh, I hope I get the answer. Let me check the answer. Wait. So one thing about doing math is that you can know instantly whether your answer is correct or wrong by checking the answer behind the book. 2y bracket 3x squared plus y squared. Yes, our answer is correct. So if your answer is wrong, then then they give us what do you call that? Opportunity to check through our solutions. That's when we learn something new. If you know your answer is not correct and you leave it at this, right, you will never learn anything. But if you know answer is wrong and then if you go and correct it, then you learn something. Okay, some learning has taken place. So our answer is correct. Happiness. All right, I don't think we have space to do part D. So I meet you in the next slide. Right, so let's look at 6D, but before that, let's write down the formula again for a cubed minus b cubed. So that will be a minus b first, followed by a squared, then plus ab, then plus b squared. Then a cubed plus b cubed will give you a plus b, then followed by a squared, then minus ab plus b squared. Okay, so let's look at 6D. So 1000 is 10 to the power of 3. So here I can combine them into bracket 10x to the power of 3. And here I can write it as y to the power of 2, then to the power of 3. Okay, if you were to, this one I'm using this, the rules of indices, we have already learned it, but just recap. And this one here I'm using. Okay, right. So I'm going to substitute this to be a, and this is b. Alright, so I have to use the difference of cube, right? Because the operation is a minus, so negative. So I will have a bracket first, followed by a square bracket, and then another bracket, then minus, bracket, 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 plus another one more bracket, close bracket. So what goes into the first bracket will be a plus b, so which is 10x minus y squared. Be careful, y squared. Second bracket will be a squared, so that is 10x then to the power of 2. Then the next one is 10x followed by y squared, and then finally y squared then to the power of 2. Okay, so let's simplify further. So this one means 10x times 10x. 10x times 10x will be 10 times 10, 100, x times x, x squared. This one will be 10x y squared. This will be 2 times 2, 4, y to the power of 4. Okay, that's it. Let's check our answer to see if it's correct. 10x minus y squared, then bracket 100x squared. I used the formula wrongly. We are using, oh, I'm sorry. You see, I also can make mistake now, so we need to be very careful. The formula is a minus b, then a squared plus, this one is plus, okay? So can you see the importance of memorizing the formula correctly? Okay, this is plus. Alright, 100 plus. Yep, we are correct now. Okay, so the takeaway from this problem is to memorize the formula correctly. Also to apply it correctly, because I remember the formula correctly, right? But then I put the sign wrongly. So to take away, memorize the formula correctly plus apply it correctly. And you want to do it well, you must have enough sleep. Okay, yeah. Ayo, this exercise like never ending or we still have 2 more questions. After question 10 is 2 more. Okay, so that's why I suggest to you to break up the exercise into different parts. Part 1, part 2, part 3, okay? Unless you have a stamina, huge stamina, you can just go through all, which I'm trying to do it now. Okay, otherwise just break it up. If not, it's quite tedious. Alright, let's look at question 10A. Okay. Can you see we're talking about same concepts, just a few concepts, and yet the variations of questions, the kind of questions they can ask, this, that, but yet you're just talking about the first, just those few concepts only. Okay, let's look at 10A. Coefficients of x cubed in the cubic polynomial is 5. Coefficients of x cubed. Okay, so we all know that the cubic polynomial is ax cubed plus bx squared plus cx, ax cubed plus bx plus cx plus d. So what we are saying is that this chap here, the coefficients of x cubed, which is the letter a there, is 5. So y is equals to 5x cubed plus bx squared. So far, this is what we know lah. But we are not going to solve for b, c, and d, right? No, okay, no way. But I'm just using this to explain to you what it means by the coefficients of x cubed in the cubic polynomial is 5. Okay, it means this one lah. Okay, all right. Okay, then what's the next thing you're told? The roots of the equations are, so the roots of equations is what we have found, like what we have done earlier, using a calculator to help you. Do you remember that I give you one cubic polynomial, cubic equation, and then you key into A, B, C, D into your calculator, and then you get the answer. So the answers is the solution. Solutions also means the roots of the equation. Okay, right. So this part here, what we are saying is x is equals to -4, x equals to -1, and x equals to 3. So this is not new. We have done this before. We're going to convert all these roots into, work backwards into, convert into linear factor. So here the linear factor will be x plus 4. This one will be x plus 1. And this one will be x minus 3. Right. So therefore, we haven't given, they want us to call this polynomial f of x. So therefore, f of x, so far, our understanding is it must be x plus 4, x plus 1, and x minus 3, right? Okay, so the catch here is, you see, if you take your x times this x times this x, you end up x3, which is 1 x3, right? That means here the coefficients of x3 is 1. Okay, which contradict to what the question wants. The question wants your a to be 5. So then where do you put in the 5? Where do you put in the 5? Yes, you just put a 5 here can already lor. Well, just put a 5 here can already. Because like what I've told you, I've shown you, if you take x times x times x, give you x cubed. Then x cubed times 5 will give you 5x cubed. And that will satisfy what they want because they want your coefficients of x cubed to be 5, right? Then we just give it to them lor. See here, 5 ready. So the answer is, let's write it properly. Oh, so if you understand how to do this question, right? Oh my goodness, the answer is just like that only. Can you see? Can you see your answer is just like that only? Really, just like that only. Okay. Find an expression for fx. Are we asked to expand it? Do we need to expand it? Don't need lah, because they never asked us to expand. So please don't go and expand it. Okay. You just ask to find an expression, and that's it. That's our answer for part A. Oh, happiness. I like this kind of question. Okay, part B. What do we do for part B? The graph of a cubic polynomial meets the x-axis. Okay, this is not difficult also. So all we need to do is meets the x-axis. Oh, means these are the solution lah. It means these are the solution. So that means your x is equals to -2. It's one answer. X equals to 1 is another answer. X equals to 2 another answer. So these are the 3 solutions. Alright, so if you work backwards, it means it's x plus 2, right? Okay, so our g of x, so far our g of x is this. But there are more conditions. Because remember, we don't know the coefficients of x cubed. The coefficients of x cubed is very important. It determines the shape of our curve. Like what we've done for 10a, right? It has the coefficients of x cubed must be 5. So I need to put a 5 in front of all your linear factors. So I need to put the a in front of all my linear factors. I don't know what my a is. Okay, a is not necessarily all the time 1. It can be any number. Okay, right. So our job now is to find a. So then how to find a? That's where your second piece of information comes in. This piece of information, you are told that when x is equals to 0, g of 0 is 12. So basically your y-intercept it's 12. Your x is 0, your y-intercept is 12. So basically this guy here, it's 12 equals to when x is 0. I really like this kind of question. It's like so sweet, and you don't need to like work until like all the cows go home already, still don't get the answers. 2 times -1, it's -2 times another -2, that is +4, right? So 4a is equals to 12, a is equals to 3. So therefore our g of x is 3 bracket x plus 2 bracket x minus 1 followed by x minus 2. And that's our answer. So sweet and simple. Okay, right. Yeah. How do you spell yeah? Yeah, okay. Right, let's look at 20. Ayo, 3 parts, part 1, 2, 3. So worthy. Okay, this one should have a lot of workings. Right, okay, never mind. You're given a polynomial f of x equals to 2x cubed plus ax squared plus x plus b. So basically there are two unknowns there. So first thing first, we have to take note is there are two unknowns there, a and b. So you ask to find the values of a and b for which, okay, you're given this is a factor. So if this is a factor, all right, so we have to rewrite it. That means we have to write our 2x cubed plus, okay, don't use such a, use a thinner one. Okay, so 2x cubed plus ax squared. Alright, so it's equals to our factor, which is 2x squared plus x minus 1. Now, what happened is that this is a quadratic polynomial. So a quadratic polynomial, if you recall, right, you have to multiply with a linear factor to get a cubic. Okay, this is what we have done earlier on. Right, so we have a quadratic multiply with the linear and then to get a cubic. So we need to find the, I can't use a and b. You know why? Because a and b is already used here. So better don't use a and b here. It's very confusing. So if I cannot use a and b, the next letter will be c, cx plus d. So basically, I need to find my unknown c and unknown d, right? So the first term is usually the easiest to find. The first term is easiest, right? You can just take this term, this, right? So 2x cubed will be equals to 2cx cubed. So divide by 2x cubed on both sides. 1 is equals to c, so c equals to 1. Then the last one will be just 1, negative 1 times d. So negative d is equals to unknown b. Oh no, so we can't do it this way, right? Can you see we can't do it this way? Too many unknowns. So this is not a good approach. So I'm giving a real demo of how some students will go about solving this and then end up in the bottleneck, right? So that's not a good approach because too many unknowns to be solved. So what I think we can do is that, how about we try to factorize this one? Can we factorize it? I'm not too sure. Let's try to factorize it and see. Yes, we can factorize it to be x plus 1 and then 2x minus 1. Okay, right. Oh, so that's easy. You know why that's easy? We can use the substitution method. So this is something like the identities we've done earlier on. The identities, yeah, identities we've done earlier on. Yes, so we can actually use substitution method. I can just substitute x to be, I can let x plus 1 equals to 0, let this one equals to 0. Because if this one is 0, remember the solving identity. If you have forgotten, then please visit one of the video I have created earlier. So if this is 0, 0 times whatever will be 0. So basically, I just wipe out everything on the right hand side. So if x plus 1 equals 0 means I'm substituting x to be negative 1. So I substitute x to be negative 1. Equals to 0. Alright, so I will have the first equation. So that will be negative 2 plus a minus 1 plus b equals to 0. A plus b equals to 3. Call this equation 1. Okay, I need to continue above. Follow the arrow. So the next thing is that I'm going to let the second linear factor here to be equal to 0. So I'm going to substitute x to be half on both sides. Right hand side will be all gone, wipe out. If you use a calculator to work this out, it's 1 over 8 times 2, that's 1/4. 1/4 a Okay, I'm going to multiply by 4 throughout to get just integer, because I prefer to work with integer. Okay, call this equation 2. So I'm going to use elimination method easier. So I'm just going to take 2 minus 1, equation 2 minus 1. So that will be a plus 4b minus bracket a plus b equals to negative 3 minus 3. So that will give me 3b equals to negative 6, b is negative 2. So once you found the answer for b, then substitute into equation 1 to get your a. So sub b equals to negative 2 into 1. A will be 3 minus b, give you 3 minus negative 2 gives you 5. Okay, right, that is how we do 20 part 1. Alright, so from part 1 we found the values of a to be 5, b to be negative 2. So we can substitute into our f of x. So f of x now is equals to our factor, quadratic factor. Remember we are saying the quadratic factor will multiply with the linear factor to give you a cubic polynomial. Alright, so this is what I need to find before I can solve it. So follow the arrow. Right, so the first term is really the easiest. 2x squared times cx will give you 2cx cubed, right? And that will be equals to my first term on the left, which is 2x cubed. So c will be 1. Then the last term will be just negative 1 times d, gives you negative d, gives you the constant term on the right, on the left, sorry, will be negative 2. So d is 2. Right, so we put everything back. You will have 2x squared plus x minus 1 multiplied with x plus 2 equals to 0. So we need to solve it, means we have to find the solution for x, the values of x. Okay, so we can factorize this further to be 2x minus 1, 2x plus 1, x minus 1. The other way around, sorry. Okay, so therefore 2x minus 1 is equals to 0, or x plus 1 equals to 0, or x plus 2 equals to 0. So therefore x is equal to half, one answer, or x equals to negative 1, second answer, or the third answer is x equals to negative 2. Okay, so that's how you do 20 part 2. Right, let's look at 20 part 3. So 20 part 3, it says that using the results that we have obtained in part I and part 2. So what is it that we have got in part I? For part I, we managed to solve the values of a, which is 5, values of b is negative 2. Then part 2, we managed to solve it to get the solution. The solutions we get is x equals to negative 2, negative 1 half for 2x cubed plus 5x squared plus x minus 2 equals to 0. So for part 3, we need to make use of these answers we got from part 1 and part 2 to solve part 3. So basically part 3 is to solve these cubic equations. Right, so in order to make the explanation clearer, okay, make the explanation clearer, I'm going to replace x with the letter a. So instead of solving for 1/4 x cubed plus 5/4 x squared plus half x minus 2 equals to 0, we're going to solve for 1/4 a cubed plus 5/4a squared plus half a minus 2 equals to 0. Basically, I just replace my x with the letter a. So what we need to do is we need to manipulate. That means I need to do some magic to this. Yeah, do some magic to make it in this form. Why make it in this form? Because we already found the answer. We already found the answer for 2x cubed plus 5x squared plus x minus 2 equals 0. We already found it to be x equals to negative 2, negative 1 half. You understand? So I'm just making use of 2x cubed plus 5x squared plus x minus 2 equals to 0 to get my answer for part 3. So I need to do some magic. So if you were to look at 2x cubed plus 5x squared plus x minus 2 equals 0, right? First of all, you see that the coefficients of x cubed must be 2. So that means I need to have 2 there first, and then something to the power of 3. I need to have a 5 there, then something to the power of 2, and then something to the power of 1. X means x to the power of 1. Then of course negative 2 then equals to 0. Okay, understand what I'm saying? So I need to do some magic to my orange guy. I need to do some magic to hit to this. Okay, to make it like this. So what is it goes inside here? That's the interesting part. Something that goes inside there and then cube it and times 2 must give me 1/4. Okay, so I don't know, right? I let the thing be B. Okay, so that means B cubed. Oh, I should not use this color. This one can't really see clearly. BA, because BA. A to the power 3 will give me A cubed, so no problem, right? B to the power 3 will give me B cubed. So 2B cubed will need to be equals to 1/4. So B cubed will be equals to 1/4 divided by 2 is 1/8. So B is half. That means I need to substitute my B to be half. What goes inside the bracket must be half A. So that, okay, so that your half A times half A times half A will gives you 1/8A cubed. And 1/8 cubed times 2 will gives you back your 1/4 A cubed, which is what you have initially here. You understand? So what I've done here is rewriting 1/4 A cubed to be 2 bracket times half A close bracket cube. Rewriting it as that. Okay, so likewise for this term here, what goes inside there is half A, because 5/4A squared will be 5 times half A times another half A, and that gives you 5/4A squared. Then the last one, of course, is half A only. Then minus 2 equals to 0. Okay, so now you do a comparison, all right? You do a comparison. Okay, this part I understand is a bit difficult to understand, but if you don't quite get it, you have to look at it a few times. Can you see now that what I've done to the orange guy is in the same format as this? The only thing is your x now is equals to half A. Your x now is equals to half A. Can you see? Right. And we have found the answers for A from part 2. Remember part 2, we already found the answer for x, which is -2, -1/2. Now our job is to find A. So therefore, what we are saying is my half A can be equals to -2, first answer, or my half A can be equals to -1, or my half A can be equals to half. And A will be -4, or A will be -2, or A will be 1. So my answers now for part 3, okay, I'm solving for x. So I have to replace my A back to be x. A is just substituted values for x, which I want to make the explanation clearer. But ultimately, your answer will not be oh, you can just do it this way lah. You can just let x equals to A here. Let x, just add in one more line, let x equals to A. Then you can just leave your answer in terms of A, because you already replace your x with A ma. So to find x is the same as finding A. Okay, so this is how you solve this question, and I know it's not easy. Okay, just go through a few times, and then you just PM me if you need more clarification. All right, happiness. We come to the last question, 23. All right, so this is supposed to be an advanced question, but actually it's not really that advanced. When it says advanced, it's because there's not much scaffolding here. That means That means basically they just throw you the problem and then you're supposed to just analyze it. But it does not mean that we have not done it before. We have done similar questions. I think this question is similar to which one? The earlier, the second, the last, third one. Cannot remember which one. Is it question 10? Yeah. 10, yeah, similar to 10B. Okay, except that 10B is guided. So it's called intermediate because it's more scaffolding. 23, there is less hints given to you, all right, but the concepts are still the same, right? So we have a cubic polynomial f of x. Okay, they already told us that they want us to call this polynomial f of x, so please don't give it other names. Okay, it's called f of x. So mix the x-axis at this, and this means these are the solution. So we have x equals to -1, x equals to 3. Okay, so if you convert it back to your linear factor, it means x plus 1, x minus 3. So far we know that f of x is equals to, okay, so far we have to assume that there is, how come there's only 2 linear factors? That means one of them is repeated. You also don't know, so don't know how, but they are given this information here. So we can make use of this. There are basically 2 things we need to know, right? First of all, remember the coefficients of x cubed we don't know. And then it cannot be just 2 linear factors, because 2 linear factors means x times x will give you x squared only, right? But the cubic is x cubed, right? So I think I need to have another linear factor here. You know what I'm saying? Because your cubic equation is y equals to ax cubed plus bx squared plus cx plus d, right? That means I need to have an x cubed here. So if I'm just having only these 2 linear factors, x times x will give me x squared only. I need x cubed, so I need a third linear factor, which I need to find. Oh, I cannot call it a. Sorry, there's already an a there. So I will just have to call it b. Oh, so how do I go about it? Oh, I got 2 unknowns I got 2 unknowns, but I have only only one information, where x is 1, then f of 1 is 16. So this is 16. When x is 1 is 1 plus 1, 1 minus 3, 1 plus b. So 16 is equals to a times 2, -2, -4a. Alright, so what happened is that I don't have any other informations, right? So if that's the case, right, then we have to go back to the questions. We need to understand the questions again. So we are saying that there are 2 roots there, x equals to -1 and x equals to 3. So most likely one of them is repeated. It has to be repeated, otherwise we cannot end up getting x cubed. Okay, so supposing x equals to 3 is repeated, then I will have twice of it, right? I will have twice of it, right? So our approach is a bit wrong really. It's not really wrong, it's correct, just that most of us will do it this way, and then we come out and then ended up like that, and then we don't know how to continue, and then we will say that there's 2 unknowns, only one equation, how to solve it, right? So that's how we have to go and revisit the question, revisit our concepts. So if you to recall that that the earlier slides I've actually introduced to you the different kind of curves, right? And then one of them is such that you can have a repeated roots here. That means you have one distinct root here, and this one is repeated. Okay, so this is a situation that's happening here. Okay, that one x equals to -1 could be repeated, or x equals to 3 could be repeated. We don't know. So that's the reason why there are 2 possible values for x equals to -3. That's the reason. Okay, right. So let's rewrite our solutions. So in this case here, x equals to -1 is repeated. Let's do case 1 first. And then we have x equals to 3. So we would have f of x is equals the a, the coefficients of x cubed. We don't know what is it, right? So we need to call it a, and then we need to find out. So if x minus 1 is repeated, then the linear factor will be x plus 1 and another x plus 1, right? And then x minus 3. So this one we can actually stack it up. Alright, so that left only one unknowns we need to find, that's a. So I have to substitute 1, 6 to the above. That means when I let x to be 1, f of 1 is 16. That means my y coordinate is 16. So that will give us 2 squared for, oh my god, I can't think. Just use calculator lah. Sometimes really just can't think, just use. So 1 plus 1 squared plus bracket 1 minus 3. 2a. I mean, you can still think lah, just that you don't want to make mistake. So a is, you can still think at all time. A is 8. Right, so therefore, so this is case number 1 now. So therefore, case number 1 is f of x is equals to 8 bracket x plus 1 squared bracket x minus 3. Then to find f of negative 3 means you substitute x to be negative 3. Right, use a calculator. 8 bracket negative 3 plus 1 squared times another negative 3 minus 3. That gives you negative 192. So that's one answer. Right, so supposing it's not x equals to negative 1 that's repeated, but x equals to 3. Right, so x equals to 3 is repeated. We really don't know which one. Okay, so we have to consider both situations. Then our f of x, right, will become a bracket x minus 3, another x minus 3, then x plus 1. So we stack these two terms up, will become like this, right? So similarly, we're going to substitute 1, 16 to the above. So this is quite an interesting question. F of x will be, okay, so when x is 1, f of 1 is 16. The y coordinate is 16. So a will be 16 divided by, sorry, something there inside the what? 16 divided by bracket 1 minus 3 squared, followed by 2. 2. A will be 2. So therefore, your f of x will be 2 bracket x minus 3 squared x plus 1. So to find f of negative 3, so that gives you 2 bracket negative 6 bracket negative 2. 24. Okay, let's get our finger crossed. Correct answer. 23. Ah! Answer is wrong. Negative 144 and 48. Where's my mistake? Wait, hang on. Oh, I hate it when, oh my goodness, substitute x to be 1. Yeah, substitute x to be 1. Correct. Well, x equals to negative 1 equals to 3. F of x is a, x plus 1, x plus 1, x minus 3. A, x plus 1 squared. Substitute 116. That is when x is 1. So 1 plus 1 is 2. 1 plus 1 is 2. It's not 2a. 1 plus 1 squared times negative 2. Negative 8 lah, yo. Ooh la la. I make a mistake here. Sorry. Negative 8. A equals to 16. A is negative 2. So our A is negative 2 here. Can you see? That's the importance of checking your answer, okay? Don't think that I have to be careful lah, okay? It's just I'm not careful. So negative 2. I'm just giving a real demo of what happened. Okay. Negative 3 minus 3. Yes, 48. Now the correct answer is correct. So I also make some calculation error here if I'm not wrong. most likely A is not 2 there. Yeah, 16 divided by 1 minus 3 squared. Some calculation error. A is 2 correct here. Substitute x to be negative 3 minus 3 negative 2. So it's 2 bracket negative 6 bracket negative 2. 24. Wait. Why did I do wrongly? 16 is equals to A 1 minus 3. 1 plus 1. 4. 4 times 2 is 8. 8A is 16. My goodness, I found my mistake. There's a 2 there. You see? Yeah. 2 bracket negative 6. Okay, you really need to have enough sleep if you want to do this. Negative 144. Here's finally. Right, and that's the end of our 4.3. Okay, I know it's very, very difficult. Alright, I can feel it. So try to break it up, break out the exercise into different parts, okay? And then don't give up. Just like me, don't give up.